So now let's calculate how much fuel you have to waste in order to get 1 kilogram up into the air. Just one. How much fuel will you need to get 1 kilogram of payload out of Earth? That's all we need. So can I rewrite my equation as dv1 over vr equals minus dm over m minus g over vr dt. So once I have that written, may I integrate? So now I have my initial mass has what? M0 has your mass of the rocket plus mass of the fuel plus mass of whatever payload you want to take. And mass final has mass of the rocket plus mass of the payload. So imagine in the final case, you've used up all of your fuel. Good? So then may I integrate all of these things? What will I get? For 1 over v, is vr a constant? It can be taken out. So from whatever v0 to whatever v final, from whatever m0 to m final, and t will be from some 0t to some t time t. So g over vr was called specific impulse time. So I'm going to replace that in here, and I'm going to call this one as 0 because I can. And I'm going to call this one another time, burnout time. Let me just define burnout time. Okay? So that means, may I make this bigger? So that means I will get 1 over VR, V minus V0 equals minus log of M final minus M initial minus 1 over specific time, T burnout minus 0. Burnout time means the time that all of the fuel has been burnt. Okay, may I rewrite this as V minus V0 over VR equals log of M0 over MF minus TB over TS. Yes? Does everybody know where the minus sign went? Into the logs, right? And you flip them. Okay. So this means I can rewrite this as V minus V0 divided by VR plus TB over TS equals log of M0 over MF, which means I can rewrite this as E to the power delta V over VR plus T burnout divided by TS equals M0 over MF. What was M0? Mass of the rocket plus mass of the fuel plus mass of the payload divided by mass of the rocket plus mass of the payload. May I rewrite this as 1 plus mass of the fuel divided by mass of the rocket plus mass of the payload? That's just algebra, right? Can I do that? Yeah. Okay, so far so good. That means E to the power delta V over VR plus TB over TS equals 1 plus mass of the fuel divided by mass of the rocket plus mass of the payload. Now, experimentally we find burnout time is about 10 minutes. And V delta V over VR and TB over TS is approximately 2. If you plug all of these values in, do you know what you find? M of the fuel divided by M of the rocket plus mass of the payload comes out to be 105. That means to take 1 kilogram of stuff out of Earth, you need 105 kilograms of fuel, which is insane. Do you know the solution to this? No.
No?
What they use are, they have those rockets that come apart and fall away.
Yeah.
So there's less mass to take as they go up. So there's less fuel to calculate. And from that calculation, I have that calculation, so if anybody's interested, you can come and look at it. What they found is doing what is called the two-stage rockets. Right, two-stage rockets reduce it to about 27 kilograms. So they reduce the amount by almost 1/3.